All right, so this is the first video for this worksheet. We'll just go over this first section, which is um, naming ethers. All right, so for A, and this is the IUPAC naming, but we'll also go over common naming methods. So for A, what you need to realize for this is that you would have to, this substituent right here, let me highlight this in a different color. Let's do it black. This is going to be our substituent on our parent chain, and our parent chain is going to be the cyclopentane ring. So we know that cyclopentane would go at the end. And then our substituent is a propyl group, but with an oxygen. So this is an ether, so it would be propoxy. So propoxy would go at the front. All right, so it would be propoxy cyclopentane. All right, for the second one here, or for B, you have to go for the longest chain for the IUPAC, right? So longest continuous chain. So it's not something like this, 1, 2, 3. You can't, it's longest carbon chain, right? So we can't include the oxygen. So it would be something like this, 1, 2, 3, or 1, 2. Clearly, it's the 1, 2, 3, right? The propane chain. So propane chain is our parent chain. And our second carbon, we have a substituent. This is going to be our ether substituent, right? And it has 2 carbons on the other side. So this is abbreviated ethyl, right? So this would be 2-ethoxy propane, right? Because propane shows that it's our longest chain, and our longest chain was this one here. And then our substituent 2-ethoxy, or our substituent ethoxy, is on carbon 2. Okay, next one. So we have 2 ways again. So this is in a scenario where you have to use the common, or let me go ahead and do the common name for B. Because there is a common name for B. Some of them there's not going to be a common name, such as C. So you would only be able to use the IUPAC name. But for the common name for B would be ethyl. So you have to look at the 2 things on either side. We have on this side of the ether or oxygen, we have an ethyl group, and on this side we have an isopropyl group. So, and it goes in alphabetical order. So it would be ethyl, isopropyl, ether. So that's our common name. Yeah. All right. So for C, like I said before, this is one that it's not going to have a common name just because you have those 2 ether substituents. All right. But we do realize that these are both methoxy groups, right? Meth, because there's a 1 carbon attached to this oxygen. So there's 2 methoxy groups, and if we can count it from either direction, we can do 1, 2, 3, 4, 5, or we can do 1, 2. This is the way we want to do it because we want our substituents on the lowest number in the carbon chain. So it would be 1, 2, 3, 4, 5. That's a pentane chain. You know it's going to be, there's 2 methoxy substituents. There's going to be 2, 2. And remember, if there's 2 of the same substituents, you have to do di. So dimethoxy. Dimethoxy, and then our parent chain, which was pentane. So dimethoxy pentane. All right. For this one, for the IUPAC name, again, you go with the longest chain. So it would be 1, 2, 3. It would be 2-methoxy. And again, methoxy, because there's this ether group, and there's only 1 carbon on the other side of it. So methyl, right? So there's 1 carbon. So methoxy is our methoxy group right here, attached to our 2nd carbon on our propane chain. So 2-methoxy propane. Or you can do the common name, but this worksheet's asking for IUPAC names. But the common name for this would be isopropyl, because you remember alphabetical order. and the I comes first for iso. So isobutyl, you take into account the I, not the B, right? So this one would be isopropyl methyl ether. That's the common name. For E, I'll give y'all just a second to pause the video and try this one out. And I hope you got it, but you should know that there's no way, at least that I'm aware of, to use a common name for this since you have two ether substituents. But we realize that each of these substituents can be labeled as a methoxy, right? So now the only question is which way do you name it? Do you count the carbon backbone? Okay, so you can do it 1, 2, 3, 4, 5, where your substituents are on carbon 3 and 4. Or you could do it like 1, 2, 3, 4, 5, where your substituents are on carbon 2 and 3. That's the way we want to do it because we want the lower numbers, right? So it's going to be 2, 3 dimethoxy pentane because we have a 5 carbon chain. Pentane. Okay. For this one, it's going to be a little interesting. So you have to, if you see this on an exam, don't stress. You should realize that you have to count, you find your longest carbon chain for the IUPAC name. So if we start here, it could be 1, 2, 3, 4, or it can be 1, 2, 3, 4. We'd probably want to start on one of these carbons just because that would put our substituents on the second carbon. Whereas if we do it from this side, it would be 1, 2, 3. It'll be on the third carbon. But if we did it from this carbon or this carbon, it would be 1, 2. So we would want to start from that side. So 1, 2, 3, 4. That's our longest chain. Once you get that, you identify the substituents. We realize there's a methyl group here and there's a methoxy group here. So now you have to think about which one is going to go in alphabetical order. Methoxy comes before methyl, right? Because that Y methyl is going to put it further back alphabetically. So it should be 2 methoxy and then 2 methyl. And it would be butane because that's our backbone. Okay. So the last one here incorporates an alcohol into the mix. So for this one, we realize that our alcohols always are going to get priority over anything else. So in that case, we would want to start our numbering on this one regardless, right? It doesn't matter because we want our alcohol to have the lowest number. So it'd be 1, 2, 3, 4, 5, and 6. All right. And the reason you can't use a common name for this is because this chain right here on the other side of the ether, like we know we can identify this one as an ethyl group, right? But this chain right here is too complex to name just because you have all these carbons on different sides of this carbon right here, and then you have an alcohol all the way down here. So it's a little bit too complex to use a common name for. So this one obviously would be IUPAC name, and IUPAC names, we go for the longest carbon chain, right? And when we deal with alcohols, we're doing with the longest carbon chain that contains the carbon of our alcohol, right? So this is the way you would write it. And then you would end up with this is an ethyl group here, right? But it's attached to an oxygen, meaning this is an ethoxy group, right? So that's going to mean, that means that we have an ethoxy substituent on carbon 5 of the carbon backbone. So we would say this is 5-ethoxy. And we have hexanol, or yeah, it's a hexane backbone, right? But you have to remember that there is the alcohol on carbon 1, so it'd be 1-hexanol. All right. Um, you've also probably seen it as 5-ethoxy, uh, ethoxy hex, and 1-all. All right, both the same thing. I think this way, the second way I wrote it is the more conventional, or it's the newer way, I believe. I'm not exactly sure though, but both of these would be correct. I'm pretty sure, unless your professor specifies that they want it in a certain way. Okay, so that's it for this video, and check out the next one where we go over synthesizing ethers through Williams and ether synthesis. Okay.